YouTube generates an immense amount of data every second, encompassing videos, comments, likes, and much more. In this video, our focus is on analyzing trending video data. By leveraging this data, we aim to perform a comprehensive analysis with several key objectives. We will examine which videos are trending and identify common characteristics among them, such as their category, the channels they came from, or the tags associated with them. We will explore whether the timing of the video publication, including the day of the week and time of the day, has an impact on its popularity or likelihood of it becoming a trending video. We will conduct text analysis on the title and description of trending videos to uncover prevalent keywords or themes. Without further delay, let's dive in and begin our exploration. We have here three files: an index.ipynb, which will contain the code for our analysis. We have US category _id.json file, a file that includes categories and IDs and their titles, and US videos.csv containing trending videos from the year 2017. So let's start our analysis. Let's open the index.ipynb and import all the necessary libraries. Check the link in the description to download the dataset. So we are going to import pandas as pd and import matplotlib.pyplot as plt and import numpy as np, import json, import cbon as sns. Then we import from the scipy .stats as stats. We will also, from the collection module, we are going to import counter, and from word cloud we are going to import word cloud. From nltk.corpus we are going to import stop words. So as we progress through this application, we are going to talk about what these imports will be used for. Then finally, we import RE, which is the short form for regular expressions. Let's add a new code block to read our CSV file and perform some initial explorations. So we type data equals pd.read csv, then we pass the file name as an argument, so usvideos.csv. This read underscore csv function can be found in the pandas module. So what we are basically doing here is to open this file and store it in the data variable. To view the shape of this data, we can type data.shape, and then hit on run all button. We have 40,000 plus rows and 16 columns for this particular dataset. Now let's print data.head to display the first 5 rows by default, unless we specify a different number in the head function. So data.head, this gives us the first 5 rows from the dataset. We can observe that we have columns such as video ID, we have the trending date, we have the title, channel title, we have the published time. We will discuss more on analyzing data types later in this video. Then we have the category ID without the names. To facilitate the analysis of categories in trending videos, we will extract the category name from this file here, us_category_id.json, and add a new column named category name to the data frame. So let's create a new variable, category underscore JSON underscore path. This is going to hold the path for this particular JSON object. So we specify the path as us underscore category underscore id.json. If we were to have our data in a different folder, we would have to navigate to that particular folder to get our file path. So to open the JSON file, we type with open, we pass in the file path, which is category underscore JSON path as file. Then we create a variable category data to hold all the content we are going to read from the JSON file. JSON.load, we pass in the file name. Then we create another variable, category underscore dict equals int category id then we get the category snippet, we have the title, for category in the category data items. Then we type data category name, which is going to be the new column added to this data frame to hold the category names. So it's going to be the data of the category ID dot map, and we pass in the category dict. What we are basically doing here is to loop through all the category ID column from our data frame, this one here, and check inside the us category underscore id.json file to look for the corresponding category name. So we have category snippet and title here. Since the US category JSON file is an object, we first have to access the snippet and title once we have the ID. So it goes like ID, snippets, and title. So let's type data.head and hit on the run button. Before we run this code, let's comment this one out, this data.head out, and run the code. So we can see the category names has been added to this data frame. Let's analyze the data types present in all columns by typing data.dtypes. Let's run this. This prints for us all the data types for each column. Next, we are going to print the number of categorical data in the columns. So we create a new code block and create a variable categorical equals variable for var in data dot columns if data of the variable dot data type d type is equal to O. Then we print the length of the categorical data we have in this data set. So categorical, when we run this, it gives us 9. We have 9 categorical columns in this data set. Let's create a new code block and analyze the relationship between videos and views. Before we start, what is a trending video? How do we define a trending video? Well, a trending video can be defined in many ways, such as looking at videos with high view, like, and comment count ratios. We could also consider the number of days a video was trending, along with its views, likes, and comment counts. We are going to opt for the latter in this analysis. To determine the count of trending days, we group the videos by video ID and trending dates and check for unique appearance. For example, let's go back to our usvideos.csv file. Pick any ID here and press Command plus F or Control plus F if you're on Windows to search for another occurrences of this ID in this dataset. So when we search for this, it gives us 14 results, meaning we have this ID appeared in the trending dataset for different days. So let's get back to our code and type trending days count equals data dot group by. We are going to group by the video ID, video underscore ID. Then we select the trending dates and look for unique occurrences. So this is going to group all the videos by ID and count them by the trending dates with the ones that appears unique. So we create another variable, trending days data frame, which is going to be trending days count dot reset index. Then we rename the trending date column to trending days. So we have here a trending dates but not trending days. So we are going to rename this to trending days. So trending days data frame dot rename using the rename function, which accepts columns, and the column we are going to select is the trending date, which you are going to replace with trending days. We are going to use in place of true, meaning we want to modify the original data set but not a copy of it. We can print trending days data frame dot head to print for us the first 5 rows of the trending videos. So we have here video IDs and the number of days they were trending. So this particular ID here is having a trending days of 6. This one are 1, 3, 4, and 3. So let's plot the relationship between days of trending videos and average views. So we create a new code block and then we create a variable mean views per video, which we are going to group the data by video ID, video underscore ID. We select the views column and calculate for the mean. We also create another variable, trending views underscore df equals pd dot data frame mean views per video dot merge pd dot data frame of the trending days count we pass in the left index of true and right index of true. So let's print trending days data frame, trending days views data frame, and this gives us the average view for each trending video. So what we are doing here is to merge the mean views per video, the one we calculated here, with the data frame of this trending days count, this particular one here. Alright, so next we are going to plot the relationship. So we are going to use the seaborn, the one we imported here, seaborn as SNS. So we type sns.implot. We pass in an S attribute. We pass in an X argument, which is the trending date, and our Y argument, which is going to be the views. Then our data is going to be the trending days view, the trending views data frame. Then we plot our S label to be the number of days trending. We plot our Y label to be the average views. Then we plot our title for this graph here to be the relationship between number of days trending and average views. So we hit on the run button. There is an error here. Module seaborn has no attribute implot. Oh, sorry. So this was supposed to be an L, not I. So L. Yeah, so yeah. This graph shows some correlations. We can see that some videos trend for just a few days. This could be videos from news source or trending issue on the internet. We also have some outliers here indicating videos that were trending for a long time. So let's create a new code block and print a pair plot to observe the relationship between all the variables, the views, likes, and comment count. So we create a variable trending days, which is going to calculate the number of trending days we have for each video. So trending days equals data.group by. We select the video ID column. Then we group by the trending dates. We are looking for unique appearances. So n-unique. Then we create a variable average metrics, which is going to hold the mean of the metrics like views, like, and comment count. So we create a variable average metrics equals data.group by video ID. We select the views, likes, and comments columns from the data frame. Comment count dot mean. Then we merge the trending days count data frame with the video ID and category name. So we create a variable merge data equals the average metrics dot merge, pass in the trending days count, comma left index of true and right index of true dot merge. We merge data, select the video ID, and the category name, dot drop duplicates. So left index of true and right index of true. Then we rename the trending dates to trending days and comment count to average comments. So merge data dot rename. We have the columns, which is the trending dates to trending days, and we have the comment count to average comments. With in place of true. So we are going to plot this using the seaborn pair plot function. SNS dot pair plot. We pass in the merge data. We create our variables. We have the views. We have likes. We have average comments. And we have trending days. So the hue is going to be the category name. So let's run this code. And there we have it. So the views in the diagonal is just plotting a variable against itself. So views against views give us this view here, likes against likes, and trending days against itself. So the other plot gives us an overview of how these variables relate to each other. So we have views and likes here, indicating, so the more likes a video gets, the higher the views as well. And we have other relationship between all the variables against other variables. So the data points we have here are for each category, as we can see here, each color representing a category. This shows the relationship between all the variables we have. So now let's analyze the popular tags found in trending videos. So we create a new code block and type top trending videos equals the trending days count dot sort values in ascending order of false, meaning we want to count from the highest to the lowest, of false dot head. We pass in an integer of the length of the trending days count. So length of trending days count. We multiply it by 0.1. So we can go ahead and print top trending videos, and it gives us this here. So we have the videos and the trending days count. Then we create a variable top videos, which is going to be the data. We select from the video ID column. Then we check if the video ID is found in the top trending videos. So we use the isIn method to check if the video ID is found in the top trending videos. Dot index. Then we create a variable to hold all the tags. So we have tags equals this pipe here dot join top videos. We select the tags we drop the tags with no values in them, drop any. Then we split all the tags by pipes. So we are splitting by this pipe symbol here because when you look through the data, we can see the tags column. Where is it? Tags. We can see the tags column are separated by this pipe here. We want to split all these tags and join them back together without this pipe. We create a variable for tag count, which is going to be the counter we imported here. This one, counter. And pass in the tags. So now we are going to create a word cloud. So the word cloud is going to show us the most popular tag in trending videos. So the most appearing tag in the trending videos is going to pop out big. It's going to show big and clear, followed by the rest. So word cloud equals the word cloud class, this one here. We give it a width of 800 and give it a height of 400 and a background color of white. So dot generate from frequencies, we pass in the tag count. All right. To plot our word cloud, we have to use pyplot. So plt.figure, we pass in the figure size of 10,5. Then plt.image show, passing the word cloud with an interpolation of bilinear. plt.axis of off. Then plt.show. Let's run this code. This shows us that some of the words tag like funny, how to, and comedy appears in most trending videos. Next, we will analyze the days and times at which videos are posted and tend to trend. We will extract useful information from the date variable using the pandas to date method for our analysis. So we create a new code block. Then we type date of the published time. So the published time contains a timestamp, this one here. We cannot make direct analysis with this dates object here, so we have to extract something like the day, the year, hour, or minutes from this published dates column. So pd dot to date time, we type data dot publish time. Then we type data, we extract the publish day from the published time by typing this publish time dot dt dot day of the week. We can also extract the publish time here. Publish time is going to be data publish time dot dt dot hour. So next, let's extract the day views and hour views. So day views equals data dot group by publish time. We select the views column. We calculate the mean of all the views, and we also get the hour views equals data dot group by. We select the publish hour, publish hour, select the views dot mean. Alright, so this is not supposed to be the publish time, but the publish day, this one here, not the publish time. So we can create a figure and access variables to hold the plt dot subplots 1, 2, and the figure size of 14 and 5. So we want to print the days view on left hand side and the hour views on the right hand side. So that's why we are creating a subplot 1 and 2 here. So we type sns dot bar plot. We have our s to be the day views. So the day views dot index, our y is also going to be the day views dot values. Ax of axis of 0. So you want to print this in the first axis. Then we create the axis. Select the first column, axis dot set title. We have the average views by day of the week. We have axis. We set the S label to be the day of the week. Axis. We select the Y label to be the average views. So we can basically copy this and modify it for the hour views. So let's change the day views to hour views. We change it here too, and instead of 0 we pass in 1 for the second column. Then we change everything here to 1, 1, 1, and instead of average views by day of the week, it's going to be average views by hour of the week. Then we change this to hour of the week and average views. This is going to remain the same. So plt dot title layout, then plt dot show. The title layout is going to print the column right next to each other without leaving any space in between. So let's run this code. We have some information here indicating videos posted on day 4 of the week. So for the pandas data frame, the day starts from Sunday. So 0 is Sunday, Monday, Tuesday, Wednesday, and Thursday. Videos posted on Thursday tends to trend the most, and video posted on the 4th hour also tend to trend as well. Let's perform an analysis of the title and description to get word cloud of words found in most trending videos. So we create a new code block. So we type data of tests equals data of title plus the data from description. So what we are doing here is to merge the title and description into this new column here called the tests. Then we create a variable stop words equals set the stop words dot words to English. So this stop word here, the one we uploaded here, stop words, is going to skip common words like we have common words like and, there, is. So these kind of words are going to be skipped and not going to be added for the analysis because they don't really make any meaning to the analysis. So you're just going to get rid of them and stop them from being parts of our analysis. We then define a function, pre-process. We pass in the tests as the argument. Then we are going to convert, or we are going to cast every argument coming through this pre-process function into a string. So we don't want to deal with numbers or any other data types. Then tests equals test to lower. So we are converting every test to lowercase. Every title and description combined together to title and the description. So we have uppercase here. This is going to convert all of them to lowercase. Then we have tests equals re.sub. The re module is the regular expressions we imported at the top. So the sub is going to get rid of any exclamation mark, any punctuations found in the title and the description. So I'm going to paste a regular expression here which is going to do just that. Next, we create tokens. We split all the tests into a token. Then tokens equals token for token in tokens if the token dot is alphabet and token dot lowercase and not in stop words. We are going to return tokens. So now let's apply the pre-processing to the test column we created here. So data of tokens, which is going to be a new column, we pass in data of the tests, this one here, dot apply pre-process. So this is going to pick every test that is in this column and apply all the processing that we defined here. We create a variable for word frequency. We initialize the counter and loop through all the tokens. So for tokens in the data tokens, we update the word frequency to be the tokens. So here we are just updating the word count. So if the function found a word like funny in the text and description, it's going to count it as 1, and then find another one, increase the counter. It repeats this for all the unique words found in the column. If a word tends to appear twice, the counter of that word is increased. So let's create a word cloud variable here, which is going to be the word cloud class. We pass in the width of 800, give it a height of 400, and the background color of white. Then we add the generate from frequencies. We pass in the word frequency, this one here. Next is time for plotting. So plt.figure, figure size 10:5, plt.imshow, word cloud, interpolation of bilinear. We don't want to plot any axis, so plt.axis is going to be off. Then plt.title is going to be word cloud of common keywords in the title and description. Finally, we type plt.show to show the plots. Let's run this code, and this shows us the popular keyword found in both the title and description, which tend to appear in most trending videos. Finally, we will create a Donta chart to represent the categories of videos that trend for extended period. So we create a new code block. Then we create a variable trending duration count, which is going to be the category name dot values count. Then we plot a figure with a figure size of 8x8. Then we type plt.py. We pass in the trending days count and labels of trending days, trending duration count dot index. Then PCT to be this. Then we calculate the start angle to be 140. We can also have a wedge prop to be a dictionary with width of 0.4. Then plt.axis, pass in equal plt.title, which is going to be trending duration category, plt.legend, we give it a title of categories and a location of upper right. So plt.show, hit on the run button. This shows that the category with the most trending videos is entertainment, followed by music, and we have how to and lifestyle. While this analysis might be insightful, it is important to note that the data is from 2017, so it might not be entirely relevant today. However, I believe this provides you with a fair knowledge on how to perform analysis on time frame data or similar data sets. If you found this video helpful, please subscribe, like and share, and also comment on what project or video ideas you would like me to do in my next videos. Thank you for watching and see you in the next one.